And so for this, we want to take some terms you're familiar with, mode, median, and mean, which are measures of central tendency, and go a little past it and explore some terms you may not be familiar with, but will be extremely important for this course, namely standard deviation and variance. And so let's start with this. I have a data set of 11 values. I tell you right here there's 11, or you could count. And I tell you this. This is the mean of something. Now, this Greek letter here, that's the Greek letter mu. It looks like a U with a tail, but that represents the mean of something. And so the mean, remember, is what we tend to think of as our standard average. You add up all the values, divide by how many there are, and I'm telling you the mean here. And so if I want to find these values, as this here, this is the variance. And the variance of something I describe right here. And we'll do one example like this, and then generally we'll use just technology. But imagine finding the difference between the mean and of each data point and squaring these differences. So imagine finding the difference between the mean of each data point and squaring it, which means everything will be positive. Then add up all these squares and divide by the number of data points. This is called the variance. And so it sounds more complex than it is, and so let's just see. I got 11 data points here, and I know the mean is 15. And so what I want to do first is look at each of these data points. For example, 3. And I want to think, what's the difference between 3 and the mean? That has a difference of 12. And then I want to square it. And I want to do that for every term. Now, it doesn't really matter what order I subtract. It doesn't matter if I think 15 minus 3 or 3 minus 15, because in the end I'm going to square it. So I'm always going to go the mean take away the value here. So next I got 15 take away 4, which is 9. Helps if I know my math, which is 11, and I square that. And I keep going. Then I got 5. The difference between 15 and 5 is 10, and I square it. Difference between 15 and 3 is 2, and I square it, and I got that twice. Difference between 14 and 15 is 1, and I square it. And then I get to the negatives here. The difference between 15 and 18 is negative 3. It doesn't really matter, though, because I square it. So it doesn't really, again, matter which way I'm subtracting, either from the mean or to the mean. And if I keep going, I get these values. I get negative 6 squared, negative 8 squared, negative 10 squared. And for the last one, the difference between 26 and 15 is 11, or negative 11 in this case, but I square it. And so first I take what I've done here. I take all the differences between each value and the mean, and I square it. I add them all up, and then I divide by how many values I have, which I can count, or I tell you there's 11. And so this here will tell me my variance, which has this symbol here. If I add up all these values now, I get 704. Divide by 11 is exactly 64. So 64 is the variance of this data. However, what we tend to use more than the variance is the standard deviation. Right? 64 is the variance. That's the symbol we use. However, for standard deviation is just the variance, the square root of the variance, I should say, and we use just this symbol for the standard deviation. And so this is going to equal just the square root of 64, which is 8. And it's a measurement of how our data is spread out. And especially standard deviation we'll see a lot. Now, aside from this question, the vast majority of the time, or maybe pretty much every time, we'll actually use our GDC to evaluate these things. Nothing I did here was difficult, but it is already pretty cumbersome, and that's with just 11 values. Imagine if we had many dozens of values, and we had lots of decimals and whatnot. And real data tends to be a bit messy. And so for the next question, at some point I want to start using our GDC, and there's many features in there that can be used to find these things. First of all, I have a new table here showing us the group data for the heights of 51 people. And keep in mind, it's broken up into these regions that span 3 centimeters in total each time. All right, so For example, if I look here, I want the mean, the median, and the mode. Well, of these, the mode is the one I can find right away. The mode is the set that repeats the most often, that it's the most frequent, and I can just see right away that's my mode. Now, well, I could say the modal class. If I ask for the modal class, we would say 159 to 161 centimeters. If I just ask for the mode, I am estimating, because I don't know how many people, I don't know the individual heights within that class. I know there was 12 people between 159 and 161 centimeters. I don't know what those individual heights were. So if we ask for just the mode, we are estimating, but we picked the midpoint between 159 and 161. And the midpoint of any two values, you add them up and divide by 2. You find the mean of them, which in this case is 160 centimeters. That's my mode. So the modal class is 159 to 161. The mode is just 160, the midpoint of that group. All right, if I want to find the mean, I could do this the fairly time-consuming way, in which for each of these, I would find the midpoint value, which I'll want to do anyways. And so when I say the midpoint value for 150 to 152, the midpoint of that is 151. Remember, if we don't know the exact data in there, we always estimate using the midpoint. So I'm going to use 151, 154 for this. Halfway between 156 and 158 is 157, and so on. So I'm writing down here are all the midpoint values. 160 is a midpoint. We used that last time. 163, 166, 169, 172, and 175. So I'm using those as for our estimate. And so if I want to find the mean, one thing I could do is go, okay, I got 3 people with an estimated height of 151 centimeters. So I could times these together and then add that to the next. I have 8 people with an estimated height of 154 centimeters. I could multiply those two together and add that, and so on. This would take a while, and I don't encourage us to do that for this much data. But if I did all of that, added up, for example, for this one, 160 times 12 plus 163 times 7, added it all up and then divided by the total number of data points, or the total number of values, which is 51, that would tell me the mean. Or, which is much, much, much better, is to, instead of doing all that those mundane calculations, let's create a table in our GDC. And in our table, we would create a 2-column table in which our first column is all these midpoint values. And the second column is our frequency. And then we can go, depending on your GDC, we can then do what we call one variable stats, and we can find these values. Now at this point, it depends on your actual GDC, but you type these 2 columns in, and you should fairly quickly see a bunch of different values, one of which is the median. Now, depending on your calculator, for example, most students use the TI-83 or the TI-84. On that, the median is shown like this, X with a bar over the top. However, it's up to you to understand your own graphing calculator. But if I look at this, I can see the median is approximately, sorry, not the median. Yeah, sorry, I'm saying the wrong words. I meant to be talking with a mean here. I'll get to the median later. The mean is approximately 161.8 centimeters. That said, I want the median, and then I'm done. The median, remember, is the same as our second quartile value, which I can see on that same one variable stats, which we used in previous lessons. Or it says, literally on some calculators like the TI-83, it says the median, which is 160 centimeters. In fact, that's not an estimate, that's exact. Well, actually I should say it's an estimate, because to be honest, in this group here, I don't know exactly how many of those people had exactly 160 centimeters for their height. I just know there was 12 people within that range. And that is why it says we're estimating here. I'm not estimating in terms of looking at the values and making up a number in my head. I'm estimating by realizing everything here, all these midpoint values here are really a type of estimation. There's my mode, my mean, and my median. Again, only the mode of which I could find immediately using my GDC, but the graphing calculator definitely sped up the rest. All right, lastly, using our GDC again, and the mid-interval values. That's what I did before. Let's calculate the estimated variance and the standard deviation. And so again, I could, if I want to make my life really painful, I could do the same idea for this, except keep in mind what I did here, I looked at each individual data point and subtracted from the mean. I mean, I do know the mean right here, but I'd have to take each of these data points. There's, these repeat 3 times, these repeat 8 times, and so on. And I don't even know what those exactly are, so I'd take this 154 and subtract from the mean and square it. And again, there's a lot of values here. So definitely an example where we want to use our GDC. And I already have the information on my screen because I used the GDC to find the mean and the median. So if I look on here, the standard deviation is the only one I can find immediately. And again, the standard deviation on a TI-84 or TI-83 looks like this. And mine says about 6.98. That's it. That is my standard deviation. That's it. On my calculator, it won't tell me the variance directly. That's okay, because the variance is just that squared. Hence the symbol is the same symbol but squared. And so all I need to do is take my 6.98 approximately, square it, and I get about 48.7. And that is the variance. And that's it. So really, we'll use these terms lots. Right now, in terms of calculating them, it really comes down to being familiar with your device, which once you use it a bit, we should become familiar with it quite quickly.